You're listening to the Things Podcast, brought to you by the Things Industries.
Kristian, welcome here. It's good to have you here on stage from Nordic. You're just busy on the booth, I saw. Thanks for making time available for a short chat. How's it going so far?
Doing very well. My first year here, and the first year for Nordic to be really present, so it's very interesting, and so happy to see Things Conference really opening up and going from very LoRaWAN focused things to also see that multi-radio, as I call it. You need not only one standard, you need several things, and then it's a place for Nordic to talk about also the things we do.
So you've got a good impression of today.
Yeah, very good, and I really like the size because it's not too big, so you can actually meet people and talk to them.
And what kind of audience? Is it engineers or management or students? What do you see?
I see a good mix. I met with students, I met with engineers, met with management level, going around looking for the next technology. So it seems to be a good mix. I still need to find some time to walk around and talk to more people, but yeah.
Interesting. So let's talk about a little bit about about your organization Nordic. You're around already quite a long time. You're European based. I think you're also producing already in Europe, or you're planning to do so. I think you're planning to do so. You're here. Well, it's being at home.
Yeah.
How's it going? Because I saw you announced some new products, or you're already. I mean, you guys are looking up now in the 3GPP world. You're looking up to satellites, right?
Yes, definitely. So now we are a fabless semiconductor company. So we do external foundries. So we both use foundries in Taiwan, but we have recently moved our leading 22 nanometer to Europe as well. So then if you look at long range and cellular side where I'm focused, our focus definitely is non-terrestrial. We are very mature stack and solution for LTE-M and NB-IoT for LB-WAN. And then we are now integrating all terrestrial support in the same module and the same chipset that we already are waiting for today. So every customer and people that want to start again also talk to satellites in the near future.
So what are you offering? Is it a chipset or a modem? Can you?
We build everything. So we build a chipset ourselves.
Chipset and a modem also.
And then we also build a module and all the software around it.
Yeah.
Kind of unique in the cellular space that they do everything.
Yeah.
We are also starting to open up and licensing chipset to traditional module vendors that go to use Nordic for various reasons. But our go-to market has been to do everything ourselves.
Okay, so suppose I was a normal, system integrator and used to use modems. I mean, the GSM technology, I think it's already 20 years old. We're talking about AT commands. So we can simply hook up a device which you have got to our device, and we can both use traditional networks, cellular networks, but we can also aim the antenna up to the satellites.
Exactly. So now we are probably starting up with like 50-ish customer now, maybe a couple of more hundreds during Q4 to start testing, and they learn, and then commercial firmware, Terrestrial, certified with terrestrial operator also early next year, and that gets people can go to market and build their own devices next year.
And just to manage expectations, what can people expect? Is it streaming data, or is it non-IP short text messages? What can we expect?
Yeah, so this is typically for use cases that I would say low bandwidth. Sleepy devices that sleep for hours, late even then, and then send a short burst of data.
Okay.
We have some interest in non-IP because obviously it's the most optimized way, but cellular typically like IP. Also, if you roam and want to go around to different operators, I think I would say that typically it will be IP-based communication, also to satellites, but try to limit the amount of data.
Okay, so we have to be careful so we have to process data on the edge, I would say. So a normal use case would be a device which is operating standalone somewhere out there, any place, anytime in the world, would say hello world once a day or hello space once a day. And then the satellite would receive it and pass it through a sort of a pickup point, or where you can reach out with the API and pick it up.
Exactly. So we see two major use cases, I would say. We say there's people that have built asset trackers or tracking things today around the world, and they want coverage everywhere, and they don't get that. Yeah. There's a lot of places no coverage, and then look for satellite as a backup, here as a external. That's one use case. And the other thing is really devices that are placed out there somewhere where you don't have any coverage, but you don't want to build your private network because you have few devices or they're far between them, and then they look for satellites.
Okay.
That's the connectivity.
And what are the things I have to bear in mind when I would like to start and develop something like this? Do they use special antennas, or what do you need?
Yeah, you will need antennas that are supporting those bands that are used for satellites, L-band and S-band, and that's all we care about.
Which frequencies then?
1.6 and 2.5.
Oh, okay, that's a new band, yeah.
So it's similar to cellular bands. We think that with a, let's say, a standardized PCB antenna that people use today for very cost optimized things, for low Earth orbit at least, that could be decent. But typically we look for more optimized, customized antenna, maybe for satellites.
Yeah.
For people that go to geostationary and want the best link budget, so lowest possible power.
Okay. And what is the difference in cost from a bill of material point of view? If you want to have a, suppose I'm making a product which is terrestrial only, traditional, or I would like to have a product which is also supporting satellites. What's the difference in the cost of the bill of material?
I think in the kind of principle phase, you can say it's the same. You can basically do the same, but then at some point, depending on your use case, you may want to invest a bit more on the antenna side.
Oh, okay.
Again, but the rest of the hardware, the rest of the software, it's the same.
Okay, listen. So you're basically saying you can already develop and design in a product which is supporting terrestrial and non-terrestrial. Standard of the shelf, it's terrestrial. And when you want to do, for example, also non-terrestrial, you can, use a standard SMA connector and connect an additional antenna.
That's a very low risk and simple path.
Okay,
Successful.
yeah, it's easy path, I would say.
So the modules that we have today, the InnoRef 51, which are flagship, that's already on hardware support of the non-terrestrial bands. So we're putting that module to the PCBA today. They already are ready for non-terrestrial. And then they need firmware for Nordic, early next year, commercial to commercial.
And what do you have to think about? Suppose I would like to have thousands of these modems. What is the cost approximately? Can you give an indication?
I think on high level, I can say that plus minus $10, depending on total errors and things. And that's, I think, is a good simple way to get connected globally.
Yeah, you're not a mobile network operator, but you could say something about costs for this global connectivity. Once a message or
Should I go on a SIM? Yeah. I think it will start from maybe a few cents and then upwards, depending a little bit.
So cost is already an issue.
No, and that's what I've said to many here, that cellular have developed a lot the last 18 months. So 2 years ago, people would say to me, cellular, too costly, too power hungry, too difficult to use. And now see a lot of all the leading guys in multimeters are starting to say cellular is the technology they want to use. They see the cost and the complexity and the power consumption is getting to a point where it's becoming a preferred technology.
And Kristian, can I say that, okay, in the end, we are going to expect that all devices, all modems are going to support satellite anyway. It's already there. It's in the stack. And if you really want to use it, just plug in an antenna.
I can't talk for all the other chipset and module vendors out there, but that is from a Nordic point of view. I can say that all our standard modem solutions now going forward will support both terrestrial and non-terrestrial. The same SKU and ordering code and same hardware. So if you're using terrestrial today and maybe you will upgrade in 3 years, you can buy another 9150 watt today and it's ready.
I would say hello world, hello sky.
Yeah.
And the sky is not the limit anymore. Thank you very much, Kristian, for being here. Thank you. Good luck. Thanks. All best. Cheers.